All right. So another test for relative extrema is known as the second derivative test because we're looking at concavity. So if you look at this right here, okay, when f double prime is less than 0, meaning your graph is concave down, f of x is concave down, this right here is a relative max. Okay? Then, if you take a look at your second derivative, which would be greater than 0, meaning concave up, you have a relative minimum. Whenever I use the second derivative test to determine relative minimum and relative max, I actually need to sketch it out because I confuse myself. That's just me. Because I want to, so far we've associated greater than 0 with increasing, concave up, anything that's positive. But here it seems backwards. A max we would think high or positive values, right? But it's concave down. So just kind of, if you have to sketch it, that's totally fine. Okay, you're not typically asked to use a specific test, okay, but you can. If it doesn't say anything, I always use the first one so I can sketch it on the line. Okay, second derivative test. So this is another one. Okay, and remember, if you're asked to use something that has to do with the second derivative, you have to be told that, even if you're not given the function, that you can take the second derivative. Otherwise, you have no idea. It might be undefined. So here it says, suppose that f is a twice differentiable function at the given point x sub 0. So you have to know that. If the first derivative is set equal to 0, meaning you find critical points from the first derivative and you plug in to the second derivative. Okay, so we're using critical points from the first derivative and we're plugging into the second derivative and we get a positive value, then f has a relative minimum. Minimum at x sub 0. Again, for the second part, if you get your critical numbers from the first derivative by setting the first derivative equal to 0, you plug those critical numbers into the second derivative and you get a negative value. You're going to get a relative maximum. Okay, let's go back to concavity for just a second to see if this makes sense. If I have the second derivative, wherever I get the critical number from, it doesn't matter. If the second derivative test gives me a positive value, am I concave up or concave down?
Concave up.
I'm concave up, like this, like a cup, right?
Yeah.
So that, oh my gosh. So this value down here on the bottom would be the relative minimum. Does that make sense? Because it's the lowest in the valley. Then here, if your second derivative is less than 0, meaning negative, that means your graph is concave down, meaning f of x is concave down. So then this is where you have the maximum.
High some hill.
There you go. Okay? Now, if, this is the key thing, if you're asked to use a second derivative test and you get your critical point from f prime and you plug into f double prime and you get 0, then what this means is the second derivative test is inconclusive. So then you might have to use the first derivative test to determine that. Typically, if you're asked a question to use a second derivative test, it's going to work out. Okay, but I mean, in a book, they might give you a question and it doesn't work. Okay, I know. So, I'm not smart enough to write the book. Okay, but just so you know, then I would just go back to the first derivative test. It's possible that you might not have any extrema there at all. Okay, so I just typically go straight for the first derivative if it doesn't tell me, because it's faster and you don't have to take the second derivative. So, in this example, it says find the relative extrema using the second derivative test. So this is very specific. I want the second derivative test. All right, so here's the process. We need to obtain critical numbers from the first derivative that we're going to plug into the second derivative. Okay, so the first thing we need to do is notice this domain restriction. This is really important here. Okay, because it's going to help us find our values on the unit circle. So remember when I told you guys to do page 6 and practice those trig values? This is why. Okay, because questions are very tricky when it comes to the unit circle. All right, so let's take the first derivative. Okay, here's something that I noticed on the test. What do I have to use when I'm taking the derivative of the sine of 2x? Yes, chain rules. Some of you, I know you knew it, but some of you skipped it. Okay, so what is the derivative using the chain rule altogether?
2 cosine 2x.
Yeah, cosine of 2x times 2, or can I say 2 cosine 2x? Thank you. I know. So generous, right? All right, so what we want to do is set this equal to 0. The problem is this is a double angle. So for those of you that kind of forgot, it's okay. What we're going to do is identify where the cosine of x is equal to 0. Because if I make this replacement, if I just call this x, I'll go back to the 2x in just a minute, we would set 2 cosine of x equal to 0. So basically, I need to know where the cosine of x is equal to 0. We'll deal with the domain restriction in just a second. But where is the cosine of x on the unit circle from 0 to 2 pi equal to 0? Pi over 2 and 3 pi over 2. So where x is equal to pi over 2 and where x is equal to 3 pi over 2. But this is a double angle. And I know this doesn't fall within the domain restriction, but this is for x, not for 2x. So then I have to go back, and I called this x, so now I need to put this back in. So 2x is equal to pi over 2, and 2x is equal to 3 pi over 2. So the angles that I'm talking about are what? Pi over 4 and 3 pi over 4. So here's my question. These two values right here that I want to use for my critical points, do they fall within this domain restriction? They do. Okay, so you can't kick this out, otherwise you'll be missing a value. Okay, critical numbers obtained, right? We got those from the first derivative. Now we want to go to the second derivative. F double prime of x. What's f double prime? We're right here. I heard negative 4 sine, yes, negative 4 sine of 2x. Okay? Second derivative. So now what you want to do is take these values and plug them into the second derivative. So we want to evaluate f double prime of pi over 4. So I'm going to plug this in. So this is negative 4 sine, what's 2 times pi over 4? Pi over 2. Yeah, don't forget your pi. What's the sine of pi over 2? 1. So this answer is negative 4. Okay, in relation to 0, negative 4, greater than, less than? Less than. So, f double prime of pi over 4 is less than 0. Okay, so let's look at what that means. F double prime, what is this then? Relative, yeah, concave down, so I have a relative max. So, this is for the first part, so I'll just write my conclusion right here. By the second derivative test, okay, by the second derivative test, if f prime of pi over 4 is equal to 0, which is what we got, and f double prime of pi over 4 we found is less than 0, then f has a relative, you just told me, max at x equals pi over 4. I know it's a lot. Okay, so we're going to basically copy this when we figure out what the next one is. Yes, I'm sorry. Sorry, did I move it over?
Yeah.
Sorry. It didn't freeze. That's all I'm worried about. Okay, so as you're writing, we're now going to test the other one. So we've got f double prime, what is it, 3 pi over 4? is equal to negative 4 sine. What is 3 pi over 4 times 2? 3 pi over 2. Okay, this is equal to what? This is equal to negative 1 times negative 4, which is 4. In relation to 0, greater than, less than? Greater than 0. Okay, so we're saying that f double prime of 3 pi over 4 is greater than 0. What does that mean about 3 pi over 4? What do we have? Relative minimum, exactly. So how would I state this conclusion? Unfortunately, I got to say it again. By the second derivative test, if f prime of 3 pi over 4
and f double prime of 3 pi over 4 is greater than 0, then f has a relative minimum at x equals 3 pi over 4.
Perfect. Great job. Okay, questions? Second derivative tests. Blah. Okay, questions on this? I know, guys, it's a lot. Here, this would be an example. It doesn't say use a second derivative test or whatever. It says use the given derivative. Ooh, they gave us a derivative. That's good news, right? Use the given derivative to find all critical points of f, and at each critical point, determine whether a relative min, max, or neither occurs, and assume that f is continuous everywhere. Okay, that's important. They gave us the derivative. Okay, so they want critical points, and we want relative max, relative min, or neither. Okay, so good news here is that what do I need to do? Make it equal to 0. Okay, so remember we had a rational function on the previous page where we had to distribute the x to the 2/3 or whatever it was. So remember we set the numerator and the denominator equal to 0 to get our critical points, right? So when I set the numerator equal to 0, you have x squared minus 7 is equal to 0. Add 7. Okay, this is where some of you fall off here. What happens when you take the square root? Plus or minus. So I have critical numbers where x is equal to plus or minus the square root of 7. Okay, now, if I set the denominator equal to 0, I've got the cubed root of x squared plus 4 is equal to 0. Cube both sides, I'm left with x squared plus 4 is equal to 0. What happens when I start to solve for any critical points of x? Look at it. I'll put it right here. X squared plus 4 is equal to 0. What's my first step? Subtract 4. X squared is equal to negative 4. Imaginary. We don't graph imaginary numbers. Here. Check. So can I use that? Okay, does everyone understand why I'm not using a critical number from the denominator? Because it's a lock, something's going to come back to me, someone's going to ask. Bless you. Okay. So, do you want to use a second derivative test? Why? Does it say to use it? Do the easy way, right? Okay.
Oh, yeah.
Number line. My gosh. F prime. The approximate value of the square root of 7. So it's between the square root of 4, which is 2, and the square root of 9, which is 3. So it's between 2 and 3, right? I don't know what it is. I don't have a calculator in front of me. Is everybody okay with that? It's somewhere between 2 and 3. So I know if I put negative square root of 7 here and square root of 7 here. Okay, I just need to test. Question. Could you write this as factors? Like if this was x squared minus 4, you'd write x plus 2x minus 2. What would this be as factors? X plus the square, oh, I just totally spit. X plus the square root of 7 and x minus the square root of 7. Why did I ask that question? Because how's this going to help me? I want to move quicker. Multiplicity. What's the multiplicity of those two factors? Odd. All right, so what's the sign? Positive. What's the sign? Negative. The sign? Oh my gosh. Done. Okay. So now what we want to know is relative minimum, relative maximum, right? We got to remember what we're talking about. So for positive to negative, we're going from increasing for F to decreasing for F, and then back to increasing. So negative square root of 7 is a relative max. Here we have a relative min. Everybody good? Okay, so this is what we've got. F, or I could say by the first derivative test. Okay, by the first derivative test, F has a relative max at x equals negative square root of 7. Is that right? Because F prime changes from positive to negative. F has a relative min at x equals the square root of 7 because F prime changes from negative to positive. Whew. Oh, negative to positive. I'm going to do a graph. Okay, I told you guys this was going to be long, so I'm really sorry.